Hello everybody, we're going to do lesson 9.8 for Algebra 1, Part 1. Part 2, Part 3 is available here. 9.8, compare linear, exponential, and quadratic models. Part 1, here is our standard here. We have a 38-point skill sheet for the classwork and 2 points for the notebook taking guide. Teachers, here's your bell work for today. You got this quadratic here. Will the path of these intersect? So students, give your students this A and B, and they haven't explained here. Give them 6-7 minutes for this bell work. Okay, welcome back. They got your solutions for your bell work. Yes, because the paths intersect, it's possible for the two objects to collide. In order to know whether the two objects will collide, one would have to know their positions at the same time and each of their speeds to do that. And are we going to provide that? Well, substitute negative 2x squared minus 3x per y in this equation and solve for x. So x equals 3.5 or x equals 2 once we substitute in. And then we factor off and then we find two solutions for x. Now substitute 3.5, 2 for x in the equation y equals ax minus 13. So we get y equals 15, y equals 3. So yes, the paths of the objects do intersect. The coordinates of the points where the paths would be here, 3.5, 15, and 2 and 3. Compare linear, exponential, and quadratic models. You've graphed linear, exponential, and quadratics. You will compare linear, exponential, and quadratic. Now, so far you've studied linear functions, exponentials, and quadratics. These functions to linear, exponential, and quadratic functions. So linear, exponential, and quadratics. Here's linear, here's exponential, here's quadratic. Here's a graph of linear, this is exponential, quadratic. Example 1, choose function using sets of ordered pairs. So use a graph to tell whether the ordered pairs represent a linear, exponential, or a quadratic function. So we have these ordered pairs here for A. So graphing A, we get this. I mean, you can look at it and immediately tell what? It's an exponential function, right? Okay. So now we got these ordered pairs here. So once we graph that, we get this here. It's what? You can immediately tell it's a linear function. And then C, we got these ordered pairs here. Then once you graph those, you get this, and it's a parabola, so therefore you know it's a quadratic function. So now, our guided practice here, tell whether ordered pairs is linear, exponential function, or quadratic. So our guided practice, here's our ordered pairs. It looks like this. Is that a quadratic, or is it an exponential, or is it a linear? Well, we have a y-intercept there at 0, negative 1.5. And then we got one up here at 2 and 2.5. Yeah, we got another one there at 3 and 7.5. So what does that tell us? The ordered pairs represent a quadratic. It's a parabola is what it looks like to me. Differences and ratios. A table of values represents a linear function if the differences of successive y values are all equal. A table of values represents an exponential if the ratios of successive y values are all equal. If the ratios, there's a key word, ratios of successive y values are all equal. In both cases, the increments between successive x values are equal. So to do this linear function, the differences of 5 minus 2 would be 3. So we have difference there of 3, difference there of 3, and a difference there of 3. That's constant. So it's a difference of 3, and then an exponential function would be like this. You have a ratio here. You have 2 here times 2, and then that's times 2, and then this would be times 2. So instead of like adding here, you're multiplying these outputs here by 2 with increments of 1 in your input. You can use differences to tell whether table of values represents quadratic function as shown. So here's quadratic for this, table of values for that. So the first differences here are -3, -1, 1, and 3. These are your outputs here. And then the second differences are 2, and then 2, and then 2. So the second differences are all constant here. That's with a quadratic. Our initial differences were not, they were what, increments here of 2, moving this way, they're moving 2, when these are 1. So what does that tell us? The table of values represents quadratic if the second differences are all equal. So the way we can tell if it's quadratic are if the second differences are all equal. Okay, identify functions using differences or ratios. Is it linear, exponential, or quadratic? Extend the table to find a y value of the next x value. So here's a table. So the first differences here are 0, 2, 4, and then 6. What's going on here? So the second differences are 2, 2, and then 2. So that should be a dead giveaway. Table of values represents a quadratic function. When x equals 3, y would equal 6 plus 18, or rather 6 plus 8, which would equal 14, I'm sorry. So when x equals 3, y would equal 14. Okay, this situation here, first difference is 3, 3, and then 3. The table of values represents a linear function when x equals 3. So when x equals 3, what would it be? It would be 13, because all these are adding up to a 3 from the previous. So this is a linear here. Okay, from the function, tell whether it's linear, exponential, or quadratic. Students, you have this one here. Pay attention so you can do yours. Okay, we have this table here. What do we got? We got a ratio here, 0.08, 0.4, 2, and 10. So each one is 5 times the 5 times the initial one creates the next output here. 5 times 2 is 10. 5 times 0.4 would be 2. And 5 times 0.08 would be 0.4, with each increment of 1 here. So with that, we have a ratio, so it means it's an exponential function because these ratios are equal here. So they're ratios. Exponential function. Ratios, not increments, not constant increments. And these will be a first difference here. There won't be a second difference. And that is 9.8, part 1. Part 2, part 3 are here. Thank you very much.